I'm Eric. I'm going to be presenting about Guardformer on behalf of our team, the work by James, Santosh, Abhishek, Mike, and myself. So just a disclaimer, this presentation does reference kind of harmful topics. Starting with a couple months ago when the character AI news broke out that a teenager was talking to the AI and ultimately decided to commit suicide. This represents a need for guardrails today, as we kind of talked about in the earlier presentations from Professor Benjo and others, that already the risks of AI are kind of at hand, and we really need to think about how to adapt to the present day of generative AI. And the key thing to note here is that there's a lot of examples that across a wide range of safety and hallucination risks, not a singular kind of risk that a lot of these guardrails in the present day, like Llama Guard, are trying to address. And so briefly, how do we ensure model safety today? We have a great workshop today around many different techniques, including post-training alignment methodologies with ROHF or inference time optimizations. But there's kind of problems with all of these. For example, we talked about how there's reward hacking or kind of these unstable ROHF training runs. And there's also kind of problems with inference time optimization with kind of susceptibility to adversarial attacks or other kinds of risks. One good thing about guardrails that we kind of address is that it's much easier, more tractable to really have a model only look at verifying whether or not content is safe or unsafe, instead of trying to understand this whole entire knowledge base of what is a more compliant, a better response. But it's not perfect. So guardrailing today, there's a lot of challenges around, again, this narrow definition that, let's say, Llama Guard or other kind of Nemo guardrails take in terms of defining safety and toxicity in one singular dimension. And then when you try to customize them, for example, for the character AI example or some other kind of error candidate example, it breaks down in terms of the transfer learning process is oftentimes unwieldy or unstable. And that means that when people build guardrails today, we often start from scratch. We take a model, maybe it is a pre-trained model from Llama 3, but we really start the guardrailing training process from scratch. And we want to aim at addressing and improving that. And there's also latency and monetary costs for this. A lot of times, for example, NVIDIA published a report around guardrailing. It kind of multiplies that cost of inference. Normally, you're paying GPT-4o, but now you have another 300 millisecond or 1 second latency from the guardrail itself. And finally, there's a lack of training recipes and data and benchmarks for guardrailing. We see a lot of great development and process around kind of general LLM training, but not the same level of kind of advancement and resources have been put into guardrails. So in our paper, Guardformer, we present a framework for pre-training and fine-tuning guardrails that hopefully extends to multiple policies. And kind of as a TLDR, we have this kind of performance improvement against GPT-4 and other kind of leading models across a variety of benchmarks, not just safety and toxicity, but across different legal and financial use cases as well. And this generalizability is key and is a result of our synthetic data pipeline that really adapts the guardrail towards a multitude of different policies. And we present that training recipe in the paper. And our aim is to really, again, just to leverage all the amazing learnings we've seen from normal LLM training and actually put that into use for guardrail development. From a high-level overview, this is a Guardformer framework where we start with a bunch of custom policies in step one, and we go through this whole process. So I'm going to step through that step by step. The first one is this policy. So if you've seen Llama Guard or any kind of similar content moderation policy, this is very similar based on that kind of template, where we have some description and allowed and disallowed behaviors. And this really allows us to kind of customize it towards anything we want. So here we show an ethics and safety policy, but we've seen a lot of enterprises or different safety institutions adapt this kind of template into something that is amenable to any kind of downstream task. And given these kind of policies, then we generate a massive amount of pre-training data. And what I mean by that is we have 100,000 synthetic different policies that we generate using Llama 3, 80B or 70B, and also generate 1 million samples across those 100,000 policies. And each data point sample has not just the data point and the label for compliance, but a bunch of metadata, right? So we're able to track the topics, the violation scenarios, the different kinds of discussion types, and across this kind of diverse kind of pre-trained data, that's where we can really leverage the same learnings we've had from regular LLMs. Given that massive pre-training corpus, then we do this kind of pre-training multitask learning step. And I'll break down into 3 different tasks. So the first thing we do is we take the model and do the regular mass language modeling task, where this is really helping the model understand in the pre-training phase how the policy interacts with the examples, with the rationale, really gets the embedding space correct in terms of this diverse 100,000 policy set. And then we have this Alice loss that really helps it generalize, right? So we added these kind of tasks kind of sequentially at first and then combined them. And so this kind of Alice loss really helps the robustness of the guardrail against new kinds of adversarial attacks. And then finally, the classification loss is a typical kind of cross-entropy loss that we have for the actual binary classification task. So that was pre-training. During fine-tuning phase, now we eliminate the first 2 tasks, and we only focus on the cross-entropy classification task. And we found that actually during this kind of fine-tuning phase, we have 2 different approaches. One is we call policy guard, which is fine-tune that full kind of model. And then Guardformer is the one that only uses kind of the classification head and only fine-tunes that layer. And I have some results later to talk about the differences. So going through this step by step, we do the whole kind of pre-training and fine-tuning process, and now let's look at the benchmarks. So for baseline approaches, we reference not only the other guardrails like Llama Guard or Nemo guardrails, but also the normal safety aligned models, let's say GP4o, as well as these publicly available content moderation APIs like Azure Content Safety or OpenAI moderation. And then we have these typical public benchmarks that we see around safety and toxicity. And we see that for Guardformer, which is the outermost ring here in purple, we have massive improvements across all of the benchmarks compared to the other baselines. And the particular thing to note here is that we see, for example, baseline approaches like the OpenAI moderation does extremely well in its own baseline benchmark, but of course struggles across the different toxicity and prompt rejection benchmarks. And so one good thing about Guardformer is, again, that pre-training process really taught it across many different kinds of toxicity and is able to generalize very well. To further investigate this kind of generalization process, we look at more custom policy benchmarks. So beyond safety and toxicity, let's look at, for example, financial advice. If you don't want, let's say, the Air Canada example of giving out discounts, how do we kind of guardrail against those kind of cases, as well as tax and legal, et cetera, different benchmarks. Here again, we see the Guardformer is the brightmost kind of column in each test, and we see that it's outperforming all the other baselines. Again, with this kind of custom policy synthetic data generation that's powered in that fine-tuning process. And beyond these benchmarks, we have some interesting insights that we've really found as a benefit of this pre-training process. The first is that we're able to actually eliminate a lot of the fine-tuning active parameters during that kind of fine-tuning phase. So I referenced earlier kind of that task around classification with cross-entropy. Here we're able to kind of only selectively train the classification head and freeze the rest of the model. And that allows us to basically train on a lot more data a lot quicker and have similar comparable results. And so you see here, the blue bar is the pre-trained model with zero-shot learning. And then the orange bar is the classification head only training, and then the green bar is a full parameter fine-tuning. And this is kind of generalizable across many policies. We only show it for 5 here, but we've tested this across 20, 30 policies. And then the other thing is the benefit is that there's fewer fine-tuning samples that are required. And so not just the layer number of active parameters is fewer, but also the actual convergence is much faster as well. And just to wrap up here, a few key takeaways and kind of future work we see that the same benefits we got from regular classical LLM training with pre-training and the fine-tune process, we can apply directly to guardrail training. And there's immense promise in terms of this field. And specifically with our small language model training, these guardrails are only 570 million parameters, which is multiple times, orders of magnitudes smaller than, let's say, GPT-4, but it's still able to beat it on these kind of benchmarks. And this makes future work around not just text moderation, but also multimodal, multi-agent moderation very promising. I want to say a big thank you to the whole Dynamo team for everyone who worked on this project. Thank you.